Yeah, last time I spoke, I was working with the Conservation District, and now I'm working with Kleinfelder, so that's great. Super fun. I'm their environmental scientist, and I work in their acid mine program. But today I'll talk to you about my thesis, which is invasive species detection using multispectral sensors on UAV. So this is just a short little agenda here. So basically, the big question is, how effective is multispectral drone imagery for detecting shrubby invasive species in mixed oak forests? Now, a lot of this is going to be very similar to last year's presentation. Again, just to review, this is my study area in Indiana County. Right here above the town, there is a 500-acre plot of land, mixed oak forest. It's co-managed between White's Woods and Co-op Park. White's Woods is owned by the township. It was acquired by Project 70. It's adjacent to town, very utilized by the community. They have some issues, deer overbrowsing and invasive species. These two issues are mainly because it's been unmanaged ever since it's been acquired. My study area has been limited by safe drone flight range and a feasible ground survey coverage. And here is White's Woods. These are all of the trails that are there, and then that's where my study area is encompassing. Site acquisition. White's Woods was acquired through Project 70 to protect land for conservation and recreation. It's to be remained mostly unused except for recreation. Timbering is not permitted. Oil and gas exploration is permitted if compliant. There has been some plans that have been proposed that have timbering included in the plans, but they've been rejected. There has been a current management plan that has been through the works. It covers canopy protection, deer management, invasive removal, focuses on biodiversity, and especially local collaboration with the university and small groups. It's DCNR reviewed. Again, it targets removing invasives and monitoring health. Japanese barberry is listed as a top threat, and this research will help them isolate where the Japanese barberry is for removal. So invasives. Invasives leaf out 1 month earlier and stay green longer than natives. There's an ideal window for drone observation when the leaf off in the overstory canopy and the invasives leaf out. So you can fly the drone and just see the invasives. There was an invasive species inventory done in 2021, but it was not specific to Japanese barberry. So you can see here, this again, the study was done in 2021. The red polygons are Japanese barberry. Mostly here you can see that it's mostly Japanese stiltgrass. A few years later, I did a quick preliminary study on Japanese barberry distribution, and it was more abundant than in the previous study. So it is growing and it is a problem. This is me flying the drone. So low altitude drones, higher resolution than satellites. Multispectral sensors can detect vegetation in the infrared. NDVI shows vegetation health. And some issues that we've come across is maintaining line of sight with local relief here. It was a very big challenge in order to fly the drone and maintain local or line of sight. So again, the flight was during overstory leaf off and invasive green out. An NDVI analysis from MicaSense, that makes no sense. The drone was flown at 380 feet above ground level with terrain follow using the Windra platform. And the images were processed using drone deploy. So this is my drone data. The RGB ortho is here, and the preliminary NDVI through drone deploy. And then this is the processing report. I flew in March of 24 using the MicaSense RenEdge-P multispectral camera. There was a 1.1 inch resolution with a pretty good horizontal and vertical accuracy down to a couple of inches. And to process, I used drone deploy. And there's me flying the drone and us doing the terrestrial survey. So my methodology, I used the modified point intercept. I came up with my own methodology. It's a riff off of the point intercept method because the point intercept method I felt wasn't really going to be adequate for the area that I needed to cover. There was over 4,000 points collected based off of presence and absence. I used a Trimble Catalyst DA2 for the accuracy. The thickets were mapped by walking the perimeters of them. And then here is the NDVI with terrestrial results. I don't know if you can see those little points there, but those are my ground. Those are me walking on the ground with the Trimble. And then here is the RGB ortho with digitized patches. So digitizing these patches off of the ortho took me a month to do. And then here is the NDVI results with the digitized patches. Here's the RGB ortho with digitized patches and my terrestrial results. And then hopefully this last photo will make a little bit more sense. So here's the digitized patches and my terrestrial results. So a couple of limitations in my next steps. This was a very short-term study window. It was only done during one growing season. Ideally, if I was doing this not for a master's thesis, I would have done multiple growing seasons, flown the drone multiple times during multiple different seasons, but I wasn't able to do that. The transect data was obtained a couple of months after the drone flight, so it gave the barberry some time to grow, and it was a little bit more flush by the time that we were out there collecting the ground data. Japanese barberry can be spectrally similar to other shrubs under certain conditions, which could lead to some classification errors. But again, mostly what is here is Japanese barberry based off of my observations in the field. But still, I have to have that. The point intercept method, I used a modified point intercept method, but I'm starting to think that I should have just used a regular point intercept method. Again, I'm learning and I'm going through this. I'm learning more about drones. I'm learning more about invasive species. I'm learning more as I go on, and yeah, so that's what this is all about, I guess. So my next steps, I just need to process the data, run statistical analysis, run a supervised classification, and defend my thesis. So that's it.